Hello everyone. In this coding problem video, we will be diving into a challenge called first and last index of the sorted element of an element in the sorted array. So the goal of this problem is to find the first and last occurrence of the target element from the sorted array. So let's dive into the problem. Given an array of integer nums which are sorted in non-decreasing order. So we have to find the starting and ending position of a given target value. So if the target value is not found, we have to return -1. So till this, we got an idea that we could directly approach a brute force to the array and we can find the first and last solution in O of n time. But it is said that we have to write an algorithm with O of log and half the time of that. So it has to be more efficient. So reading this prompt, we understood that the array is in non-decreasing order. That means the array is sorted. I will give a small demonstration of how it will be. So the array is sorted and we have to find the starting and ending position of a target value. We can see in this test case that 5, 7, 7, 8, 8 and 10 are the array and the target value is 8. So the first occurrence of the target value is at the position 0, 1, 2 and 3 and the last occurrence of this target value is at 4. So we have to return 3, 4. That's the problem. In the second prompt, we can see that target value is 6, but there is no 6 at all in this array. So we'll be directly returning the output. Suppose there is only one target value. Suppose we see 5, 7, 7, 8, 9, 10. This is our array and we have to find 9. So 9 is at the position 3, 0, 1, 2 and 3, third index. So we'll be returning 8 itself because that's the starting as well as ending value. So that's the whole problem. So as we have to do it in O of log n, this is all about searching. So we know linear as well as binary search. So the optimal one will be binary search. So we have to find the starting and ending value. So at first we have to find the target value. So the approach we'll be trying here will be, we are finding the target value at first using the normal binary search. So when the target value is found, we are looking into its left part. So when the target value is found, we are setting it. Like I'm giving a new way, like index. I'm setting that index as mid when the target value is found. So we know that now the current index is 3. Okay, I'm setting that, okay, I found the value at third index. Now I'm going to check whether the value is there on the left part of this array. Left part of the array means first you will be doing a binary search. This will be the middle value. Then it is lesser than the target value. I will going into this part. So this will be the middle value which is greater than the target value. Then I will come into this part. That's the only element left. So that's the middle value. That's also the target. So we are directly setting that index is equal to this position. That is 3. 3 is the position. So as I told, next the thing we will be doing is we have to find the starting position as well as ending position. So we are doing the same binary search. So the idea here is we are doing the same binary search on the left part of this array, left part of this target. So same binary search in the sense, let's take that example itself. Look, this is the example. So same binary search when you are applying into the left part of this element. This is the target value we found. Left part of this element means, okay, sorry, in this array this will be the middle value which is directly the target. So we have to find whether it is a starting position. So we are searching it in the left part of the array where there is no element at all. So this will be returned as directly because we are returning this index. So whenever we are finding the middle value, we are setting it as the index. Then we'll be doing the approach. Similarly, for finding the right side, we'll be checking it on the right side. Look, in this right side, we are again applying the same binary search to find the target value. So when the target value is found here, we will be changing the index to that middle value. So that's the whole approach behind this. So basically, we are writing 2 binary searches on left as well as right. Have to find the starting and index, final index. We can directly put a flag value to check whether we are doing the right or left. So I hope you understood. Let's dive into the code. So at first I told we have a condition that when the target value is not found, we have to return -1 and -1. So the final will be my answer. I'm just giving a list that is -1 and -1. So this will be my returning value. So I'm changing this when the target value is found. Changing these indexes of 0 as well as the 0 as well as 1. So at first what I'll be doing is I want to find the 0th element. So here I am applying the binary search. Calling another function where I will be passing the nums as well as target value. Similarly for the second one also, which is the second half, that means the ending position of nums as well as the target value. So this will be the last index and this will be the first index. Okay, so that's the idea behind this. Now we are going to write the problem for binary search. So we'll be returning this array. That's the final answer. So next we are directly writing the code of binary search, which is a nested function inside this. These are the nums and this is the target. So the normal binary search code where I'm setting the low as 0 and high as the last element, that is length of nums minus 1. Now let's go into the loop where we are checking whether the conditions satisfy between them, and I'm going to set the middle value, that is low plus high by 2. High by 2. Now I'm going to check if the num's middle value is the target. So I will write this code now. I will tell what happens here. It's not like directly returning the mid value. As I've told, we have to check again recursively into the left part. So what we're doing here is I will write the conditions for the other one. If the mid value is greater than the target, setting the height to the left side, checking only the left part, else we are checking only the right part. So we have a condition here, like when the middle value is target, I told like I will be setting the index value as mid. So we need an index value here. I'm giving declaring another index, and I'm setting into -1. -1 in the sense, if it is not there, I will be returning that -1, which will replace this one. That's it. That's not, there is nothing much in that. So if that is the target value, if the middle value is the target value, as I have told, I have to check in the left part. So we have to see, like, it's basically these two functions are same. So we have to set a condition that this is for the first half and this is for the second half. So I will be declaring a flag here to 0. So when the flag is 0, I'll be doing it on the left side, and when the flag is 1, I'll be doing it on the right side. So just in case to give that condition that is left as well as right side. So here I'm just declaring the flag. Now I'm going to check whether it is left or right. So if inside this, when the target is found, at first, okay, sorry, at first we have to set that index as middle value. Now the index is in the middle. So this actually helps to return back the middle value if there is only one element. So that's the idea behind this. So every time we are finding that, we are just setting the index value. So if the flag is 0, that means it is in the first half. First half in the sense, the high will be mid -1. Sorry, mid -1. Else, if flag is something else, I have to return high will be, no, low will be mid +1. That means the second half. Binary search itself on the second half. On the second half. Okay, so this will be like on the first half. So that's very simple. I hope you got the idea behind this, and it will keep on running. So it will only take off log n time, because when after searching the middle value, most of the parts will be gone. So we'll be doing it on the left or right to find the starting index. So this